fragment which sets PA4 high delays the MPU exactly half a second with a 2,097,152 Hz external oscillator, and sets PA4 low, delays another half a second, and repeats using only intersecond delays. Use subroutines. Okay, here they have provided that external is 2,097,152. Write that one down. External is 209,7152 Hertz, and there's a relationship between external and the internal clock. That is, internal clock is 1/4 of the time of external, so we can use that here. External divided by 4, external is 209,7152 Hertz, and that one divided by 4, and that's gonna give us that gives us 524,298 cycles per second. But here, based on the question here, is we had to look at this one for half second, so we had to divide this one again by 2. So if we divide this one again by 2, that is 262,144. that is cycles per half second. Okay, now we can start writing our code. This is the number of cycle we have to achieve. Okay, now we are going to write a code that's going to have a delay cycle that is giving this many number of cycle. To do that, first also they have mentioned we have to set PA4 high and also PA4 low. So for that one, what we have to do is we have to just load 16 for PA4 high and 0 for PA4 low. Let's see how to do that. So first we start here, and then we load accumulator A with the 16. So you can use binary, that is percentage sign, or you can use the hexadecimal as well. In hexadecimal, that will be 2 digits, because if you are loading accumulator A, that takes 8 bit. It's only do 8 bits at a time. So we in hexadecimal, that is only 2 digits, because each letter in hexadecimal is 4 bits. So that's going to be just 1 0 in hexadecimal. But if you write it in binary, you have to put 8 digits. So that's going to be 0 0 0 1 and then 0 0 0 0. Okay, this is in binary. Now store accumulator A, and that is port A, and then jump to subroutine JSR, and that the subroutine is delay. This one we are going to create later. And this is for the PA4 high. Now PA4 low we had to load with 0. PA4 high we had to load with 16. So PA4 low we load with accumulator A, and here same thing, we put 8 zeros, and then STAA port A, and then JSR, again jump to the subroutine delay, and then BRA, that is branch always, that is to start. Okay, now I have to keep on going down. I don't have space. I'm going to create a new page and continue this. So now I'm going to create the subroutine. It goes, that's delay, and here what we are going to do is we are going to load index x with a value that is to help us with the loop, because we are going to run a loop that's going to run certain amount of time to create the delays, create the cycles we want to achieve. This many cycles we want to create. So I use this subroutine, and here I load the x value with a certain number. We had to decide this one after using a calculation to do that. So first I'd leave it blank without loading anything, because we are going to decide that to a number later what to load with. So this one takes 3 cycles, and once it loads, we are gonna create a loop to enter. So let's call the name of the loop as delay loop. And in this loop we are going to decrement x, and to decrement it's going to take 3 cycles. And then we are going to put a statement bne. This is branch not equal to 0. So if not equal to 0, it's keep on looping. So to loop back, we have to mention the name of the loop, that is a delay loop in our case, delay loop. And this one takes 3 cycles. So since we are using subroutine, now we have to return from subroutine, so we have to put a RTS, and that one takes 5 cycles. Okay, now I have to decide what value to put here based on the cycle I want to achieve. So here I want to achieve 262,144 cycles. So we have to create a number of x to achieve that result. So here this 3 happen only one time, because first it enter this, then we are going to load a value, and that only takes 3 cycles. Once it load the value, it's going to enter the loop, and this loop keep on happening based on whatever value we put here. So we have to figure out, if I put which value, that will give this many number of cycles. So to decide that, I'm gonna go ahead and create an equation. So here first 3, this one only happen once, and also after it finish the loop and exit the loop, this also gonna happen just once. So 3 plus 5, and this loop is going to keep on happening based on the value we put right here. So to find that one out, I put an x for it, and then these 2 things are going to keep on looping. So that's going to be 3 plus 3 right here, and that should give us this many cycles, that is 262,144. 62,144. Now let's solve this one. So here, if I solve for x, this is going to be 6x is equal to 262,144 minus 8, and that is 262,136, and we have to divide this one by 6 to find out the x value. So 262,136, if I divide this one by 6, and if I get a whole number, we don't have a problem. But in case we don't get a whole number and we get a fraction value, then what we have to do is we have to use one of these 2. Like we can use either brn, that takes 3 cycles. Okay, this is not included in the code. This is just I'm explaining, like, in case if we have a fraction value, we can use these to achieve the cycles. Okay, so no, also we can use that, only takes 2 cycles. So based on the requirement, we can apply one of those to achieve the result. So let's go ahead and divide this one and see what we get. So I use my calculator. 262,136 divided by 6, that gave me a fraction value, like that is 436,089.3333. So we cannot apply this number because we are getting fractional. So to find out what is the value that can be divisible by 6, I have to look at what is the next even number, because odd number is always going to be a fraction value. So I have to look at what is the previous even number for this. So if you look at that, that is 262,134, and divide that one by 6. 262,134 divided by 6. That's giving me a whole number. So that is 43,689. So that's good. So I can just put that number right here. 43,689, and also we have to put an ampersand sign, because if we don't put this, it's gonna point to the address, and then that's going to be a different story. So to mention this is a decimal value, you have to put this number sign right here. So once you put that, then this loop is going to run this many times and going to create, but two cycles is going to be missing because we took 2 out of it, right? So let's calculate again. Let's see how many we are going to miss if we take 2 out of it. Okay, wait a minute. So this is the number we want to achieve, 262,144, and we just reduce the 8, so that become 36, and we just took 2 out of it. So I can just put this one knob right here. That's going to take extra 2 cycles, and make sure you put it after the loop, because this one should be happening just once. So after the loop we put a knob, and that's going to take 2 cycles. And now if we apply this, if we put x value this and plus 2 for this, then we are going to get this number back, okay. And that's how you can find out, what to put in and what not to put in and stuff like that. Like in case if you need 3 more, then you can use this, because the less is better. If you need 3, you can use this. If you need 2, you can use this. In this case we only needed 2 more, so we use the knob here. Okay, this is just for the explanation, and this is the main code, and that's gonna achieve this number of cycles we need. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my